Hello everyone, welcome to CPDict. In this video we are going to look at the solution of problem B from today's Codeforces due to round 675. Let's get started. The problem is called nice matrix. So what they're saying is a matrix of size n into m is called a nice if all rows and columns of the matrix are palindromes. So if we look at the rows and columns separately, the numbers should be arranged in such a way that all the columns and rows are palindromes. And we have been given an input matrix. We need to convert it into a nice matrix, and we need to find out the minimum number of operations we need to perform. In one operation, we can either increase the value of any element by 1 or we can decrease the value of that element by 1. So yes, let's see what we can do. Yes, and the constraints are the value of n and m would be within 1 and 100. So yes, let's see. Suppose we have a given matrix of this size. Say I'm writing down the elements of 1 2 3 4 5 6 7 8 9 10, again 1 2 3 4 5, and let's go 10 9 8 7 6. So they want us to convert it into a nice matrix in that way. And if we look at this element, and it comes in the first row and the first column, so it should be equal to this element as well as this element. And if you see, these two elements must also be equal to this element. So if we are looking at one element, we should be considering all these four elements. As the rows and columns should be palindromic, ultimately we need to convert these four elements into some value such that all four of them should be converted into a single value. Let's say it is x. Okay, that's the main point. Now let's see, I have picked these values and I have arranged in ascending order. So it would be 1, 5, 6 and 10. Let's try to plot them in a line. Let's say the numbers are d1, d2, d3 and d4. As we want all of them to have a same value, so what we can do, and yes, let's say this gap is x, this is y, and this is z. Yes, so I was saying we want them to have equal values. So what we can do, we can convert all of them to d1, or we can convert all of them to d2 or d3 or d4. These are the four values which we can convert these values into. Let's say we are converting all the values into d1, then the amount of or the number of operations we need to do is, first of all we need to move d2 to d1, which will take us x. We need to move d3 to d1, which will take us x plus y, and to move d4 to d1, it will take us x plus y plus z, z which is equal to 3x plus 2y plus z. This is one. This was for d1. Similarly, to make all the values of all these elements equal to d2, what we need to perform operations like x plus y plus z, which is equal to x plus 2y plus z. Similarly, to get d3 value as the same value for all these, it would be exactly equal to 2y, x plus 2y plus z if you find out the equation. And for d4, if you want to convert all these values to make them equal to d4, for d1 we need to move it by x plus y plus z. For d2 we need y plus z, and for d3 we need z, which is equal to x plus 2y plus 3z. So these are the three operations. These are the three operations we can perform such that these four values are exactly same. So as we want the minimum number of operations, what we can do, we can take the minimum of these three values. It will tell us what are the how much, like what's the least number of operations we need to perform such that all these four values are same. So we'll take the minimum of these three, and we will be doing for all such pairs. Like we'll find all such pairs. Like for the second pair, suppose we are talking about this element, now it should be equal to this element, and if we are considering columns, then these two should be equal to this 9, and this 4 should be equal to this 7, and also 9 and 7 must also be same if we are considering this row, as the rows should also be palindromic as well as the columns. So in that case we would be considering these four values, 2, 4, 7 and 9. Again we will find out these gaps x, y and z. From these values find out these three, from these three questions we'll find three values and then take the minimum of it. We'll do this for all such pairs, and if you see, we just need to move to find out the pairs. We just need to move till this point. We only go to till this point, because if suppose we have moved to 4, then we will be considering its opposite number would be 2, which we have already considered earlier. So we only need to go to n by 2 column, and similarly for the row we need to go till m by 2, because we in that way we have considered all the pairs. But there is one special case. Suppose we are having odd number of values in our column or row. Suppose I'm just talking about column. You see, this one would be matched with this 5, this 2 would be matched with this 3, but we are left with 3, this 3, that is the middle column. But we also need to make sure that this middle column is also following the palindromic property. So in that case we will just need to see this column. Suppose this column is having values 5, 6, 7, then we will try to make this this column a palindromic one. Will match 3 and 7. We'll move one of those to the other one. Either we will make 3, convert 3 into 7, or we can convert 7 into 3. It will take equal number of operations. Then we'll take 4 and 6, and we do not need to do anything for 5, as there is no other number which is matched to 5 if we are considering columns. So whenever we are considering 4 elements, we'll go till n by 2 to m by 2. But if the number of columns are odd or the number of rows are odd, then for that row which is placed in middle of our matrix, and for that column which is placed in middle of our matrix, if the number of columns rows are odd, then we'll considering it separately, as I've explained. So yes, that's all for the explanation part. Let's see the code now. Yes, I've taken the input. Initially my answer is 0. Now I'm traversing till m by 2 and n by 2. This is the row and this is column. Now I'm finding out those other three values, other three indexes. Like let's say I'm considering I'm at this point. Now I'm finding out the index of this 5, this 10 and this 6. It can be just find out by if this is at index I, it can be find out by n minus 1 minus I. This will be the index of its pair, which it should be matched. Similarly, to match it with the row, then I would remain the same in this case, and j will remain the same in this case, and I will remain the same in this case. In this case, j will change to this value. And if we are talking about the index of this 10 and we are currently at this one, then I will change into m minus 1 minus I, and this would be j. not 1 because I am considering rows, and j will remain the same. Similarly, we can find out the index of this. So I find out the index of other 3 elements. Now I am taking the minimum of, like yeah, this thing is not really required. I was thinking about this earlier. Now I found out those 4 values which I was talking about. Then I sorted my vector of these 4 values and find out. Then I found out the difference between adjacent difference between the elements which I was talking about, which is x, y, and z. So yes, this is d1, d2, and d3. I've taken the minimum of those 3 equations which I had explained earlier, and then I'm adding it to my answer. And for if the number of rows are odd, I'm considering this case or taking care of that row separately. Similarly, if the number of columns are odd, then the middle column, I'm handling the middle column separately, and at the end I'm printing the answer. Yes guys, that's all for this problem. I hope you understood it and kind of liked it. It would be great if you like our video, share it with your friends, and consider subscribing to our channel. Guys, okay, I'll see you in the next video. Till then, take care. Happy coding. Adios amigos.